Develop equations of lines. The first objective is finding the slope of a line given 2 points on the line. The slope m of a line through points x1, y1 and x2, y2, which are pictured here. So you see x1 is just the x value of the first point, y1 is just the y value of the first point, x2 is just the x value of the second point, and y2 is just the y value of the second point. So what we're going to do is we're going to define something called the slope, that is a measure of the steepness of the line. It's defined to be the ratio of the vertical change, delta y, where delta y is just the change vertically from one point to the next. And you can find delta y by simply subtracting y2 minus y1. So delta y is just that distance there. And it's the ratio of that change, of that distance, to the horizontal change, delta x, which is x2 minus x1. So x2 minus x1 is that distance right there, and it's the horizontal change. So here's the formula for slope. The slope is the ratio of the rise, delta y, to the run, delta x. Delta y is just y2 minus y1. Delta x is just x2 minus x1. Let's look at an example. This example asks us to find the slope m of a line through the points negative 6, 1 and 3, 16. So we have a rough sketch over here, not drawn to scale. So you see x1 is negative 6, y1 is 1, x2 is 3, y2 is 16. So we can label those here and plug them all into this formula. y2 16 minus y1 1 over x2 3 minus x1 negative 6. But 3 minus negative 6 is actually 3 plus 6. So this becomes 16 minus 1, 15, or 3 plus 6, 9. We need to reduce this fraction though. They both have a factor of 3, so I divide the top and bottom by 3 and get 5/3. So there I have the slope of the line. The slope of the line is 5/3, and I've answered this question. And that's how you find the slope of a line given 2 points on the line. Let's look at another objective. So the next objective is find the point slope form of a linear equation. So the point slope form of the equation of the line with slope m that passes through the point x1, y1 is given by y minus y1 equals m times x minus x1. Let's use that in an example. Find an equation of the line with slope m equals 5/3 that passes through the point negative 6, 1. Write the equation in slope-intercept form. First, we're just going to plug everything in. We have m is 5/3, we have x1 is negative 6, and we have y1 is 1. So we plug all that in. But then x minus negative 6 is actually x plus 6. And all we have to do is take this point slope form of the equation and convert it to the slope-intercept form. To get it in slope-intercept form, which is y equals mx plus b, I need to solve it for y and also get rid of these parentheses. To get rid of the parentheses, I can distribute. So I'm going to do 5/3 times x is 5/3 x. Then 5/3 times 6, well, that's 30/3, which is 10. Now I can bring down the left side of the equation. And the last step, the last thing I need to do is just add 1 to both sides to get the point or the slope-intercept form of the equation. So I add 1 to both sides, and I get y is equal to 5/3x plus 11, because 10 plus 1 is 11. This is the slope-intercept form of that equation of the line that has this slope and goes through this point. Let's use this same process on an application problem, a real-world application. A demand function defines the relationship between the price P of a product and the quantity Q of the product demanded at that price. You notice that Q can be written as a function of P. D is the name of that function. D stands for demand. Now let's look at the example. At a price of $92.30, the daily demand for a certain product is $45,500. So this is a price. This is the amount demanded at that price. At a price of $96.20, the daily demand of the same product is 43,400. So letting the price P be the independent variable, that's the first component of an ordered pair, and the daily demand Q be the dependent variable, that's the second component. So basically P is X and Q is Y. Create a linear demand curve of the form dP equals M times P plus B. So first we'll organize the information. We'll make a table. The first column of the table will be the independent variable P, which is just like X. The second one will be the dependent variable Q, which is just like Y. We need to find the slope if we're going to come up with an equation. The slope formula changes now because instead of X's and Y's, we have P's and Q's. So now we have this as the slope formula. We're using these as the Y values, so it's going to be Q2 minus Q1 over P2 minus P1. So Q2 is 43,400 and Q1 is 45,500, while P2 is 9620 and P1 is 9230. So putting those into the formula, we get this formula here. $43,400 minus 45,500 divided by 9620 minus 9230. The numerator gives us negative 2100. The denominator gives us 3.9. So what we want to do is we want to move the decimal once on the bottom, but in order to do that, we move the decimal once on the top to clear the decimals. We'll get negative 21,000 over 39. And we can reduce this fraction because 3 goes into both. 3 goes into 21,000 7,000 times, and 3 goes into 39 13 times. So we get this as the slope of the line. With this slope and the point P1, Q1, we can use the point slope form. Q minus Q1 is equal to M times P minus P1. We can use that point slope form to come up with an equation. So we'll plug everything in. It's going to be Q minus Q1, which is 45,500, is equal to M, negative 7,000 over 13, times P minus P1, where P1 is 9230. So we plug all that in, and then we're doing the same thing. We're going to simplify this. We're going to put it in slope-intercept form. Y equals mx plus b, or in this case, q equals mp plus b. So we need to solve this for q. We're going to get rid of the parentheses by distributing. So it's going to be negative 7,000 over 13 times p, which gives me negative 7,000 over 13p. And negative 7,000 over 13 times negative 9230 is going to be positive 49,700. I'll bring down the left side of the equation. Now all I need to do is add 45,500 to both sides. I'll get this equation here. So add 45,500 to both sides. I get this. This is my demand function. So Q, we said, is a function of P. So we can write it this way. dP is equal to this. This is the demand function. It's the demand as a function of the price. So if you give this thing a price, it will be able to tell you what the amount demanded will be for that price. Here it says, same problem, same example, except now we want to find the daily demand if the price is $91. So I saw what the daily demand was at $92.30 and at $96.20. Now I want to see what the daily demand will be at $91. So I'm going to just plug P into dP. Here's dP. And the P I'm going to use, the price is $91. So I plug that $91 in here, and I get negative 7,000 over 13 times 91 plus 95,200. I do this multiplication here, and I get negative 49,000. And then when I combine these like terms, I get that the price here is going to be, that the demand at a price of $91 is going to be 46,200. An interesting thing would be to see which price gives us the greatest revenue. You could find that out by multiplying the price by the quantity demanded to find out how much money was made, and then comparing all those different revenues to see which one was the maximum.